This is changing, of course. Market-based mechanisms are becoming more prominent in the U.S. But we can look at pollutants in the U.S. and we can assess them for how they look and what they look like. So a number of things are certainly points to look at and say that was good, maybe not cost effective, but it was a good thing that we did. So we've achieved national improvement in air quality from 1980 to 2019 pretty significantly. If we just look at sort of some of the more conventional pollutants, we can see this. So let's actually do this. So I'm going to pull up some data here into my STATA module, and then we're going to look at some time plots of pollutants over time with respect to the US. So let me just call up my data. Oops. Helps if we can spell correctly. So what we're going to do here is we're going to drop if ABV is not equal. So we're going to drop every country. This sample has virtually every country in it in their conventional pollutants. Again, we'll look at some other countries again as well. But for now, we're just going to look at the US because we want to give that policy history. So we're going to drop every country but the US. And so now what we want to do is I'm just going to do some statistical things real quick, and then I'm going to show you a time plot of some various pollutants. Okay, so let's do TS line, and let's look at CO2, for example. So if we look at CO2 over time, it's certainly risen. The general trend of CO2 has been upwards over time. But we can see that there have been several instances in which there's been reductions in CO2. Students often wonder what happened here? What was this? This is the stagflation era of the United States. So this was a massive, massive recession. And, if you ever wanted to defend the idea that CO2 is related to economic growth, the fact that CO2 rises during rapid economic growth and then falls during recessions is a pretty good argument there. We see again that there's this decline here in emissions also during the 2009 period. However, we can see that decline actually started to occur before that. And so overall, the US experience with CO2 is that it's been a pollutant we've kind of ignored. So if we look at, the EPA has sort of had a blind eye towards CO2. Why is that? Well, when your policies are based off of human health considerations, the fact is that CO2 doesn't really affect human health. So it's been a pollutant that we really haven't done much about until the sort of recent era. And now we're starting to see some sort of decoupling of the relationship between economic growth and environmental, CO2 emissions. So, okay, so now let's consider let's consider another pollutant. So let's look at methane, for example. So here we see a lot of success. So methane definitely was a conventional pollutant that during the Clean Air Act amendments of the early 1990s, you can see that decline happens almost exactly at 1990. We can see rapid decreases in methane. This is great in respect to climate change because in fact, methane is a heavier fossil fuel than CO2, warms the earth quicker than CO2 would. And so this reduction in methane is absolutely fantastic. A lot of this reduction in methane came from cleaner automobiles, cleaner engines, and cleaner extraction sites with respect to natural gas and just cleaner industrial production, generally speaking. So again, very little in terms of decreases in methane when the Clean Air Act and the Clean Air Act first came online. But then in the 1990s, with those amendments, we see rapid decline in methane to the extent that methane isn't necessarily a pollutant we're that worried about today. Although if we allow it to increase, that would certainly be a reason to worry about it. Let's look at noxious. That's funny. Let's look at NOx, nitrous oxide, noxious oxide. That sounds like a good podcast title. Again, you can see similar sort of behavior, although we started to take care of our NOx problem. Looks like it sort of started in the 1980s, but again, with those clean air amendments and clean water amendments as well, we see the rapid decline in measured nitrous oxide in the United States. So again, a good outcome for pollutants. And then let's look at particulate matter. So again, remember we looked at those standards and we saw that things like methane, nitrous oxide, these tend to be about concentrations, and then particulate matter, this is about, just the pollutant itself. So let's see, how have we done with that? Massive improvement, however, only very, very recently. And a lot of this has to do with the decline of the coal industry. So coal-fired power plants are one of the main sources of particulate matter pollution, as well as just industrial production like steel smelting. This is why Pittsburgh in the Industrial Revolution would be like pitch black during the day because of steel mills. And, that was a lot because of particulate matter. And so we can see, again, once we gave the EPA teeth in the early 2000s, we actually see dramatic declines in particulate matter in the US. So again, a success, but a success that came, over 40 years after the creation of the Clean Air Act. So I think it's sort of a contextual, success story. One of the more important sort of reasons why we reduced pollution in the US, specifically the pollutant SO2. I don't have data on SO2, but just you can trust me that SO2 increased in the US until about the late 1980s. And then again, with those clean air amendments in the early 1990s, we saw declines in SO2, which were largely caused by the Reclaim Project in the US. Which were smog trading schemes that were used in large cities in California where they had massive smog problems, specifically in cities like LA. And these policies, these programs, basically allowed industry polluters to pay for the ability to pollute and then to trade those ability to pollute to other firms. Now, if you watch the video on the second equimarginal principle, we saw that this actually is one of the ways in which we reach cost-effective policies by allowing firms to trade permits with each other. What we do is we get the high cost firms, that is the firms that cost a lot to reduce pollution. We get them to buy pollution permits. And so they don't spend a lot of money on pollution reduction because it's very expensive for them to do so. And then the low cost, the firms who are able to reduce pollution cheaply, they sell their pollution permits to other firms and they abate their pollution. And this was not only a cost-effective policy, but it also worked. So massive reductions in SO2 and just generally the smog problem declined significantly in California in the early 1990s and through on, and to the point now where the US doesn't really have an existing smog problem. It used to be a big problem in the US. It still is a problem in other places. China, for example, has large smog problems, but doesn't happen in the United States. And a lot of your developed countries, again, Tokyo, for example, had a small smog problem, but it virtually non-existent today. So if we're going to talk about the sort of role of environmental economics, we sort of want to think about now kind of, so what's the argument moving forward? So we've just given some history. We looked at some pollutants. We looked at, their behavior. So moving forward, how do we get to more cost-effective policy? Well, obviously in this class, we've talked a lot about market-based mechanisms. The one specific to pollutants is called an emissions charge, which is basically just putting a tax on pollutants, like making polluting a costly endeavor in addition to the cost of production or in addition to the cost of consumption. And so therefore, what we do is we establish different types of charges. So an efficiency charge is set up to enforce or achieve an efficient outcome by forcing the polluter to compensate completely for all damage, right? So any damage is created, the charge is for that exact amount. The cost-effective charge is going to be designed to achieve an ambient standard at lowest possible cost. So it's going to allow for some damages, but damages which are either within the threshold of human safety or human health, or within those ambient standards. And again, because ambient standards are in fact higher in terms of, they control pollution more than health standards, ambient standards are actually a good baseline, sort of the precautionary principle view of pollutions. Now, the thing about emissions charges is they have to be set by administrative process. So you have to have a regulatory monitoring apparatus in order to do this. And so there's cost associated with that as well. I duplicated a slide there. I was really confused. I was like, what's going on here? I was like the X-Files theme, playing in my head right now. Now, the big thing in the U.S., or not, I shouldn't say the big thing in the U.S., but one of the big things in the U.S. and in other parts of the world as well is this idea of regional pollutants. So, because the EPA tends to focus on this idea of like attainment zones, one of the things that they can do as well is they can think about attainment zones not just by states or by counties, but they can think about them as regions. So not just the north, just not just like New York, Connecticut, in those states on their own, but we can think about the entire Northeast as an area of pollution, because there are, of course, mobile sources of pollution. And we're going to talk about that in here coming up in the next video. And so we have to assess this. We have to understand what this means for some notion of attainment zones, right? If the basis of environmental protection is going to be about establishing attainment zones and about, either command and controlling our way to reduce pollution or using market-based mechanisms like emissions charges to reduce pollution, then we need to have a well-established idea of to what extent the pollution represents a cohesive area. Where does the pollution exist? Is it a local problem? Is it a state problem? Is it a regional problem, or is it a global problem? Right? I mean, that's, CO2 is a global pollutant. SO2 is more of a local to regional pollutant. Lead is a local pollutant, for example, right? So there's all these different areas where the sphere of influence changes with respect to these types of pollutants, right? Again, some substances can be both local and regional, like I just mentioned with respect to sulfur oxides like SO2. The approach of dilution is the solution. So what does this mean? It means that the problem with these types of pollutants like sulfur oxides is, again, that concentration. We want to keep that concentration low. So in other words, we want to, in a sense, dilute the amount of sulfur oxides that are making it into the atmosphere. And so in order to dilute it, one of the ways that we do it is we clean SO2 before it goes in the atmosphere. So if you look at a lot of modern smokestacks, what we've required, or what businesses have done on their own through, simply reacting to regulation, is they've put scrubbers on the top of smokestacks, and specifically scrubbers which reduce the amount of SO2 which is ultimately released into the upper atmosphere. And so, we can make companies put those scrubbers in, which we have at times, or we can incentivize them to put those scrubbers in by having them pay for their pollution. And so again, we have to think about this in terms of the cost-effective approach, and dilution as a solution is basically an argument for incentivizing businesses to clean some of their pollution before they emit it, as opposed to simply controlling what they emit themselves. Again, this idea of the sulfur allowance trading program that we just talked about was an example of, dilution is the solution. And the last thing I'm going to talk about, and it is very true of the US, and not just the US, but in other parts of the world, but certainly true of the US, is this idea of implicit subsidies. So with implicit subsidies, the idea is that the way in which we price certain things in the economic system leads to the implicit subsidy of some very damaging environmental problems. So personal automobile use is a great example of this, where we make personal automobile use very cheap in the US. Roads, for the most part, are free to use. Even in the context of tolls, usually the tolls aren't very expensive. Up until recently, for example, it was very cheap to drive into Manhattan. Only within the last 10 to 15 years have you seen the cost of driving into Manhattan substantially increase. And as a result, we're not even getting close to what actually that car that is creating in terms of environmental degradation, as well as congestion problems, just in terms of taking up space. And so there's sort of an implicit subsidy with automobile use in the US, where it doesn't align with our general goal of trying to reduce pollution. And so we have to be very careful of those implicit subsidies. Things like free parking, downtown free parking, they're great for individuals to enjoy, but again, they incentivize car use. And car use historically and even today is one of the largest sources of CO2 emissions in the world. Transportation generally is our CO2 problem, whether it's boats, airplanes, or automobiles. Certainly, buildings themselves create and manufacturing processes create a lot of CO2, but a lot of CO2 is driven by individual decisions, taking an airplane, sending a boat full of cargo, driving, things that are necessary, things that a lot of people have to do, but we make them cheap so people do more of it. Right? We can make those things more expensive, and we would do less of it. And so, and instead of having an implicit subsidy, a lot of our economists argue we should in fact be taxing these things. So by taxing CO2 and having that affect things like automobile use, shipping costs, what economists argue is that we would be removing that implicit subsidy and we would get less of it. Right? So that's the basic idea. So that's a big issue, right? A lot of implicit subsidies show up a lot of different places, and not just in terms of CO2, but when it comes to how we dispose of waste, for example. There's implicit subsidies for us not having a good idea of how businesses are dealing with their waste. And so if we don't have an apparatus in place that actually understands how businesses are emitting, how businesses are dealing with their waste, then what we do is we make their dumping of that waste completely free. So historically, right, when New York City was just dumping its trash into the ocean, that was an implicit subsidy. That was taking trash collection and trash processing and making it very, very, very cheap. And by making it very cheap, we did a lot of that. And it really wasn't until the last few decades that we stopped massively dumping trash into the Atlantic Ocean from New York City, and arguably a lot of that's still going on. So again, the EPA has been successful in areas, but there's still a lot of work to go. And part of that is because for a long time, the EPA, even after it was established, was fairly impotent in what it was able to do. And we've seen, partly just because of a larger pressure on politicians coming from the citizenry, coming from environmental groups, but also I think the influence of environmental economics, we've seen a much more concerted effort of dealing with pollutants on that more case by case basis, whether it's setting standards, whether it's deciding what policies are actually deal with that. Command and control policies for lead versus market-based mechanisms for CO2, for example, is something that is born out of a discussion that uniquely involves environmental economics.